Welcome to doassignment-ca. Here is the problem. Blocks A and B of mass 10 kilograms and 6 kilograms respectively are placed on an inclined plane where theta equals 30 degrees and released from rest. They are connected by a rigid link. The coefficients of kinetic friction between the blocks in the inclined plane are mu sub A equals 0.1 and mu sub B equals 0.3. Neglect the mass of the link. Determine the force developed in the link. Now, let us work through the solution step by step. We start by checking what each block would do if it were free on the 30-degree incline. Using the formula g times sine 30 minus mu times cosine 30, block A gets a free acceleration of about 4.6 meters per second squared, while block B only gets about 2.36 meters per second squared. Because A would move faster than B, we initially assume the link is in compression, meaning A is pushing B. Both blocks share a common acceleration. The total mass is 16 kilograms. The gravity component pulling both blocks down the slope is 78.48 newtons. We compute the normal forces separately, 85 newtons for block A and 51 newtons for block B. Multiplying by the respective friction coefficients gives friction forces of 8.5 newtons for block A and 15.3 newtons for block B, both acting up the slope opposing motion. Applying Newton's second law to the whole system along the incline, the net force is 78.48 minus 8.50 minus 15.30, which equals 54.68 newtons. Dividing by the total mass of 16 kilograms gives a common acceleration of 3.418 meters per second squared, directed down the slope. We isolate block B with mass 6 kilograms. Writing Newton's second law for block B along the incline with the link force assumed to push up the slope, we get 29.43 minus 15.30 minus the link force equals 20.51. Solving gives a link force of negative 6.38 newtons, which means our compression assumption was wrong. The link is actually in tension. Block A is pulling block B. Correcting the direction, the link force is 6.38 newtons in tension. As a verification, we isolate block A with mass 10 kilograms. The gravity component down the slope minus friction minus the tension in the link must equal 10 times the acceleration. Plugging in, 49.05 minus 8.50 minus the link force equals 34.18, giving a link force of 6.37 newtons. This matches the result from block B within rounding error. Confirming that the force developed in the link is approximately 6.37 newtons in tension. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.